Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haytham Aly, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today, we will have a new quiz to recall the Airbus A320 flight control system, Chapter 27. We will have a set of questions to recall and to refresh your knowledge regarding the Airbus A320 flight control system, Chapter 27. So let's join the quiz now. I will join the quiz now. Haytham Aly. And let's have the quiz right now. Okay. Chapter 27 Flight Controls quiz number 1. Okay, question 1 of 27. Which surfaces are used for lift dumping? Which surfaces are used for lift dumping? All spoilers, spoilers 1 to 3, spoilers 1 to 4. The right answer is all spoilers. All spoilers. If you remember, the Airbus A320 have 5 spoilers on each wing, numbered from wing root to wing tip. We have 5 spoilers. 1, 2, 3, 4, and 5. All spoilers, the five spoilers are used for lift dumping. Lift dumping, once the aircraft land, all spoilers are deflected to very high degree to spoil the lift. If we speak about lift dumping, all spoilers. Is there other spoiler or other functions the spoiler do? Yes, the spoiler in flight may have a roll function and speed brake function. Roll function and speed brake function. For roll function, spoilers 2 to 4, 2, 3, 4, and 5, 2 to 5, I'm sorry, 2 to 5 are used for roll function. And spoiler 2 to 4 are used for speed brake function. But all spoilers on ground are used for lift dumping function. Okay. Next question, everybody. Question 2 of 27. Which surfaces are used to control the roll? Which surfaces are used to control the roll? Spoiler 1 to 5, aileron and spoiler 3 to 5, aileron and spoiler 2 to 5. For roll function, yes, aileron and spoilers 2 to 5 are used for roll function. As I mentioned before in the last question, we mentioned spoiler number 2, number 3, number 4, number 5 are roll spoilers. They are helping the aileron for roll function. So the right answer is, which surfaces are used to control the roll? They are spoilers 2 to 5 plus the aileron on each wing. So what about the speed brake spoilers? If you remember, spoilers 2 to 4 are speed brake spoiler. Spoiler number 2, 3, and 4 are used only for speed brake function. So we have a common spoilers 2, 3, and 4 maybe do roll function and maybe do speed brake function. If these orders are requested at the same time, this spoiler will do both function, but they are giving priority to roll function because it is a primary function. So again, aileron and spoiler 2 to 5, 2, 3, 4, and 5 are used for roll function or are used to control the roll function. Okay, everybody, very good. Let's proceed. Question number 3. Which surfaces in the A320 family can also be mechanically controlled? Elevator and THS, aileron and THS, rudder and THS. The right answer is Rudder and THS. Rudder and THS can also be mechanically controlled. In case of all flight control computer failure, or in case of total electrical power failure, the pilots can still have a hope and control the rudder and THS mechanically from the cockpit. The rudder can be mechanically controlled from the rudder pedal, and the THS can be mechanically controlled from the trim wheels on the center pedestal. So yes, rudder and THS can also be mechanically controlled in case of total electrical power failure or total computer failure. Very good, everybody. Let's proceed. Next question, question 4 of 27. Normal law don't provide a full flight envelope protection. True or false? Normal law don't provide a full flight envelope protection. This statement is false because normal law provide a full flight envelope protection. For example, angle of attack protection, speed brake protection, theta protection, bank angle protection. All these protection are available in case of normal law. You remember the flight control computer, which are the main computer for the electrical flight control system, may control the flight control in either three laws: normal law, alternate law, or direct law. In normal law, full flight envelope protections are available. In alternate law, protections are available but reduced protection. In direct law, yes, still we have fly-by-wire, but no protection are available in direct law. Yes, it is an electrical flight control system. Yes, it is a fly-by-wire, but the computer will not provide any protection. The computers will not provide any protections. Okay. So as you can see here, this is a flight control computer. Take the order from the side stick or the autopilot and do a protection. So this is the fly-by-wire. Signal from the side stick or autopilot are go in a wire, and there is a computer in between the surface deflection and the controller that do provide protection if the computer are available to control or to process in a normal low condition. Full flight envelope protection available. So if you ask yourself, when we degrade from normal law to alternate law or direct law, it will depend on number and nature of failures. For example, if a hydraulic system fail, for example, if an adrio fail, this failure will control or will degrade the normal law to alternate law or direct law. Okay, everybody. Let's proceed. Next question. Question 5 of 27. In direct law, all the protection are lost. In direct law, all the protections are lost. This statement is true. Yes. In direct law, we are not having any protection by the computer. Still fly-by-wire, still electrical flight control system, but without any protection. Whatever the pilot requests or the autopilot requests, the aircraft will behave. The computer will not play any role, will not process the signal coming from the side stick or the autopilot. So yes, in direct law, all the protections are lost. Okay, everybody, let's proceed. Next question. I hope you enjoy this quiz to recall the Airbus A320 flight control system. Okay. Next one. Question 6 of 27. In normal condition, what are the active protection in flare mode? In normal condition, what are the active protections in flare mode? This is the flare mode, as you can see here, flare mode. So we have bank angle protection and stall protection So in normal condition, the active protection in flare mode, bank angle and stall protection. Bank angle and stall protection. Okay, so the protection are processed depending on the phase of the flight. If we are in ground low or ground mode, flight low, flare low, and ground low again. So as you can see here also, in flight low we have high speed protection, stall protection, bank angle protection, speed protection, angle of attack protection. These are the protections available in flight thanks to fly-by-wire, thanks to electrical flight control system, everybody. Okay. Let's proceed. Next question. Question 7 of 27. What are the active protection in direct law? What are the active protection in direct law? In direct law, no protections are available. No protections are available. So remember, yes, direct law fly-by-wire, electrical flight control system, but the computer will not provide any protection on the pilot order or the autopilot order. Okay, everybody. Let's proceed. Next question. Question 8 of 27. How is it possible to inhibit the output of the other side stick? How is it possible to inhibit the output of the other side stick? By pulling harder than the other pilot, by pressing in takeover push button. The captain is always right. So what do you think? How is it possible to inhibit the output of the other side stick? By pulling harder than the other pilot or by pressing in takeover push button? By pressing in the takeover push button, yes. We have on the side stick a red push button. This red push button may be used to disconnect the autopilot or to have priority, To have priority, it's the same that to inhibit the output of the other side stick. Okay, how you can take priority? By press and hold on the red push button for almost 40 seconds to take priority, So, is it possible to inhibit the output of the other side stick? Yes. How? By pressing in the takeover push button on the side stick. Okay, everybody. Let's proceed. Next question. Question 9 of 27. How can a deactivated stick be reactivated? By a momentary action on the takeover push button of any side stick, by pulling on the deactivated stick harder than the other pilot, by simultaneous action on both takeover push button. So, by a momentary action on takeover push button of any side stick. So, again, this question, how can a deactivated stick be reactivated? By a momentary action on the takeover push button of any side stick. Okay, everybody. Okay. Let's proceed. Next question. Question 10 of 27. THS mechanical trim has less priority than electrical trim. Trimmable horizontal stabilizer. Mechanical trim has less priority than electrical trim. This statement is false. Yes. Why this statement is false? Because mechanical trim always has priority over electrical trim. Mechanical trim of the trimmable horizontal stabilizer always has priority over electrical trim. Okay. So this is a trimmable horizontal stabilizer, as you can see. It is operated by THS actuator, hydraulic motors, which are operated by 3 electrical motors. 3 electrical motors. Okay. Next question, everybody. Question 11 of 27. Both elevator actuator become active in large beach demand. Both elevators actuator become active in large beach demand. Yes, this statement is very true. This statement is very true. You remember each elevator has 2 actuators. And each actuator can be operated in active, damping, or centering mode. Active, damping, or centering mode. In normal operation, if there is no large beach demand, the actuator of the elevator, one will be in active and the other will be in damping mode. But only if a large beach demand is requested by the pilot. For example, large beach demand requested, that requests the elevator to operate with a high rate. In that case, a double pressurization request happen to the actuator of the elevators, and both actuator will be operate in active mode, not active damping, in active mode. So yes, both elevators actuator become active in large beach demand request. Both actuator of the elevator become active, not active damping, active. Okay, everybody. Okay. Let's proceed. Next question, everybody. Question 12 of 27. The 4 elevator actuator are in centering mode when mechanical backup by trim wheels, pitch controlled by normal law in elax, pitch controlled by alternate law in elax. The right answer is mechanical backup by trim wheels active. Yes. As I mentioned before, the actuators of the elevator may be active, may be damping, may be centering mode, operate in centering mode. When this centering mode will be done or will operate in case of mechanical trim by the trim wheels happen, in case of all electrical power failure or all computer failure, the pilot will use the trim wheel to mechanically control the trim wheels, to mechanically control the THS. Only in that case, the elevator actuator will operate in centering mode. What is the centering mode? The centering mode will be applied in both actuator of the elevator in case of mechanical backup to center the elevator with the THS. To center the elevator with the THS, because now the pitch control will be done by the trim wheels, mechanically from the trim wheels, and the THS will be mechanically controlled, not electrically controlled. Okay, everybody. Let's proceed. Next question. Question 13 of 27. Mechanical backup by trim wheels active if all computer lost, total electrical failure, all the mentioned above. Again, mechanical backup by trim wheels active if all computer lost, total electrical failure, or all the mentioned above. The right answer is all the mentioned above. As I mentioned before, the trimmable horizontal stabilizer THS can be mechanically controlled also by the trim wheels from the center pedestal, and always the mechanical control of the trim THS has priority over electrical control. And when the mechanical control will be active, in case of all computer lost, all computers inoperative, or in case of total electrical failure, we cannot operate in EFIS, electrical flight control system. So the THS will be operated mechanically from the trim wheels on the center pedestal. From the trim wheels on the center pedestal. On the center pedestal. Okay, everybody. Let's proceed. Next question, everybody. I hope you enjoy this quiz to recall the Airbus A320 flight control system. Okay. Are you ready? Let's proceed. Question 14 of 27. All ailerons actuator revert to damping mode in case of. All aileron actuator revert to damping mode in case of a double ELAC failure, green and blue hydraulic low pressure, either the mentioned above happen. The right answer is either the mentioned above happen. Yes. In case of double ELAC failure, okay, the actuator of the aileron refer to damping mode, and the roll function will happen by the roll spoilers. Roll spoiler, thanks to the roll function from the spoiler. Thanks to the roll spoilers. Also, in case of green and blue hydraulic low pressure, green system fail, blue system fail, you can see the right aileron and the left aileron are operated by two actuators of each, one by the green and one by the blue. So in case of a green and blue hydraulic low pressure, the aileron actuator will revert to damping mode, and the roll function will be done by the roll spoilers. Roll spoilers. So again, a double ELAC failure will take us to roll function by the spoilers. And the green and blue hydraulic low pressure will take us to roll function by the spoilers only. And in that case, the aileron actuator will revert to damping mode. Damping mode. Each actuator of the aileron may be active or damping. For the aileron actuator, they are operated in two modes. May be active, may be damping. Okay, everybody. So both revert to damping in case of double ELAC failure, ELAC 1 and 2 fail, or green and the blue hydraulic low pressure. Green and the blue hydraulic low pressure. Okay, everybody, let's proceed. Next question. Question 15 of 27. In case of loss of the green hydraulic pressure, the roll is achieved by. In case of loss of green hydraulic pressure, the roll is achieved by aileron and spoiler 2, 3, 4, and 5. Aileron and spoiler 2, 3, and 4. Spoiler 2, 3, and 4. The right answer is aileron and spoiler 2, 3, and 4. Let's explain this question. In normal operation, the roll function happen by aileron and spoiler 2 to 5. Aileron and spoiler 2 to 5. In that case, the question asks, we lost the green hydraulic pressure. So here, the green actuator will be in up, but we still have the blue actuator. So, yes, we still have an actuator to operate the aileron. Okay. And spoiler 2, 3, 4, and 5, only spoiler 5 operate by the green hydraulic pressure. So we still have yellow and blue. So spoiler 2, spoiler 3, spoiler 4 operated by the yellow and the blue hydraulic system still will be operated. Only we will lose spoiler number 5. So in case of loss of the green hydraulic pressure, the roll is achieved by an aileron, because the blue hydraulic actuator still operates, and spoiler 2, 3, and 4, because only spoiler 5 will be lost, because green hydraulic system fail, or green hydraulic pressure lost. Okay, everybody. Thanks to the spoiler roll function, because here in the Airbus A320, we have roll function happen by the aileron and spoilers 2 to 5 on each wing. Spoilers 2 to 5 on each wing. Okay, everybody. Let's proceed. Next question. Question 16 of 27. How many hydraulic systems power the rudder? 1, 2, or 3? The right answer is 3. Hydraulic systems are available to operate the rudder. 3 hydraulic systems are there to operate the rudder. 3 actuators, 1 powered by the green hydraulic system, 1 powered by the yellow hydraulic system, and the third powered by the blue hydraulic system. Blue hydraulic system. This is the rudder trim panel. Rudder trim panel. From here there is a selector to trim the rudder from the 0 position. We still have plus or minus 20 degree, left or right, 20 degree. And from here you can reset the rudder again to 0 position. Rudder again to 0 position. Okay, everybody. So how many hydraulic system powers the rudder? They are 3. 3 hydraulic systems. Okay, everybody, let's proceed. Next question. Question 17 of 27. Which signals cause rudder pedal movement? Which signal cause rudder pedal movement? Rudder trim signal, yaw damping signal, turn coordination signal. Only rudder trim signal cause rudder pedal movement. Only rudder trim signal cause rudder pedal movement. In case of yaw damping function happening automatically by the electrical flight control system, the rudder pedal will not move. In case of turn coordination function, because the rudder also may be used for turn coordination with the aileron for turn function. Also, if the turn coordination function by the rudder happen, the rudder pedal will not move. But only if an automatic or manual rudder trim happen from the panel or from the autopilot to compensate, for example, for thrust asymmetry, only in that case you will find that the rudder pedal will move. So again, which signal cause rudder pedal movement? It is the rudder trim signal. Rudder trim signals. Okay, everybody, let's proceed. Next question. Question 18 of 27. Following a hydraulic system failure in flight, what does each spoiler do? Following a hydraulic system failure in flight, what does each spoiler do? We have a statement here: the surface can only be moved toward the retracted position pushed by aerodynamic force, and it is a logic. So it is retracted by the biased servo valve, it is retracted by aerodynamic forces and locked. It is locked and stopped in its actual position. So the right answer is, it is retracted by aerodynamic force and locked. So again, following a hydraulic system failure in flight, what does each spoiler do? The spoiler will be retracted by aerodynamic load and will be locked in the retracted position. Okay, everybody. Next question, question 19 of 27. Which computer controls the rudder trim actuator in manual mode? Which computer controls the rudder trim actuators in manual mode? The FMGC only, the fax only, the FMGC and the fax. If you can see here, rudder trim in manual modes, you will trim the rudder from the selector here. Signal coming from the panel to the fax. So fax only will control the rudder trim actuator. Fax only will control the rudder trim actuators. So again, which computers control the rudder trim actuator in manual mode? The fax only. Also, which computer controls the rudder trim actuator in automatic mode? The fax and the FMGC. In automatic, the FMGC will send the signal to the fax, and the fax will control the rudder trim actuator. But in manual mode, signal coming from the rudder trim panel directly to the fax. So the fax only, the fax computer, flight augmentation computers, will control the rudder trim actuator in manual mode. In manual mode. Okay, everybody, let's proceed. Next question. Question 20 of 27. With one slat flap control computer inoperative, both slat and flap system operate at half speed, slat system operate at half speed only, flap system operate at half speed only. So with one SFCC inoperative, both slat and flap system operate at half speed. Both slat and flap system operate at half speed. Each slat flap control computer has one slat and one flap channel. And in order to operate the slats and flaps at full speed, both SFCCs must be operated. If one SFCC inoperative, both slat and flap system will operate by a full torque at half speed. By a full torque at half speed. At half speed. Okay, everybody, let's proceed. Next question. Question 21 of 27. In a slat or flap power control units, BCU, if one motor is inoperative, hydraulic failure or SFCC failure, the remaining motor provide half output torque at full speed, full output torque at half speed, full output torque at full speed. Again, in a slat or flap BCU power control unit, if one motor is inoperative, may be due to hydraulic failure or SFCC failure, the remaining motor provide full output torque at half speed. Full output torque at half speed. Because the slat and flap BCU, they are similar. They are operated by two hydraulic motors. Two hydraulic motors. For the slat, one motor by the blue and one by the green. For the flap, one motor by the green and the other by the yellow. So for example, if green hydraulic system fail, so for the slat we still have the blue motor and for the flap we still have the yellow motor. Each of them will provide full output torque but at a half speed. Full output torque but at a half speed. Also in case of one motor inoperative because it's SFCC failure, in case of one slat flap control computer failure, the remaining motor will provide full output torque but at a half speed. At a half speed. Okay, everybody, let's proceed. Next question. I hope you enjoy this quiz. And you remember this is for informal training to enhance your performance and to refresh your knowledge regarding the Airbus A320 flight control system. Okay, next question. Flap sensor consist of what on each interconnecting strut on each wing? Yes, we have flap sensor interconnecting the inboard and outboard flap. Each flap sensor consists of 2 proximity sensor, 1 proximity sensor, 3 proximity sensor. Flap sensors are 2 proximity sensors. We have 2 proximity sensor on each interconnecting strut connecting the inboard and outboard flap. Because if a failure happens, this sensor will tell the landing gear control interface unit to tell the slat flap control computer that there is a mechanical failure between the inboard and outboard flap. Inboard and outboard flap. These flap sensors are of a proximity sensor type. So they can tell only the LGCIU, and the LGCIU will tell the slat flap control computer. Slat flap control computer. Okay, everybody. Let's proceed. Next question. Question 23 of 27. What are the consequences of one flap BCU motor is inoperative? What are the consequences of one flap BCU motor is inoperative? The system is locked and the flap further movement is impossible. No consequence, the movement of the flap surface is not affected. The flap surface extend or retract at half speed. The right answer is the flap surface extend or retract at half speed because only one motor is inoperative. We still have another motor. because the flap or slat BCU operated by two hydraulic motors interconnected together by a gearbox. If one motor is inoperative, we still have another motor. But in that case, the other motor will extend or retract the slat or flap at half speed. What failure take us to one motor only? If in case of hydraulic failure or SFCC failure, or slat flap control computer 1 or 2 only fail. Okay, everybody, let's proceed. Next question. Question 24 of 27. To which electrical flight control system computer the centralized fault display interface unit connected? To which electrical flight control system computer the centralized fault display interface unit connected? To the ELACs, only to the FCDC, flight control data concentrators, to the ELACs and 6, to the elevator aileron computer and spoiler elevator computer. From this schematic, yes, we have the centralized fault display interface unit connected to the flight control data concentrators, only to the flight control data concentrator. Okay, everybody, okay. Flight control data concentrator are used for flight control monitoring and maintenance, flight control monitoring and indication on ACA. And also for maintenance, because the FCDC are connected to the centralized fault display interface unit. Centralized fault display interface unit. Okay, everybody, let's proceed. Next question. Question 25 of 27. To which electrical flight control system computer is the flight warning computer connected? To the 6, only to the FCDC, only to the ELACs and 6. Also, flight warning computer are connected to the flight control data concentrators. So the right answer is only to the flight control data concentrators. Okay. So let's remember, what is the computer constitutes the electrical flight control system? Computer constitutes the electrical flight control system: ELACs, elevator aileron computers, 6 spoiler elevator computers, FAC flight augmentation computers, FCDC flight control data concentrators, and FMGC flight management and guidance computer. Okay, everybody, let's proceed. Next question. I hope you enjoy this quiz and recall the Airbus A320 flight control system. Okay. Question 26 of 27. Once the wingtip brake have been applied, is it possible to reset them in flight? Yes, by making any new selection from the control lever. Yes, by making a reverse selection from the control lever. No, reset is only possible on ground through the centralized fault display system. The right answer is no, reset is only possible on ground through the CFDS. Wingtip brake may be applied due to failure, asymmetry or overspeed, okay, between the left or right slats or flaps. Okay, so wingtip brakes, if they are applied in flight, they can only possible to be reset on ground, because reset is only possible on ground through the CFDS, centralized fault display system. Okay, everybody, let's proceed. Next question. Question 27 of 27. Wingtip brakes solenoids energized in case of overspeed or runaways. Yes, this is two conditions that allow the wingtip brake to be energized. Solenoids of the wingtip brake may be energized in case of asymmetry, runaway, overspeed, uncommanded movement. So yes, in case of overspeed or runaway failure, the solenoids of the wingtip brake happen to stop and lock the system. So this statement is true. This statement is true. So again, wingtip brakes, solenoids energized. In case of overspeed, yes. And in case of runaway, yes. Okay, everybody. Thank you for your good listening. I hope this set of questions allow you to recall the Airbus A320 flight control system. These questions prepared by Haytham Aly, your aviation technical instructor. Welcome to my aviation nuggets, and I hope you enjoy this quiz. And please stay tuned for upcoming sessions like this. Thank you for your good listening, and I will meet you again. Bye-bye.